Hi everyone and welcome to today's lesson. Here we're going to learn how to prove identities. So here is an example and the question is we want to prove the following identity, which basically means we want to show that this left side is the same as this right side. Now please don't get confused with proving identities and equations. Equations want us to solve for x, but that's not the question. The question is prove that this left side is equal to this right side. So we are going to follow normal simplification rules. Now what I usually do is I follow the 3 steps over here. I will start by trying to simplify my numerators and denominators. Well, this is only one term in my numerator, so I cannot simplify it. Here in my denominator, we are asked to plus, but we cannot plus these 2 terms because they are totally different. So I cannot simplify. Then I go to factorization. Well, we know we are going to factorize this denominator because there's a plus in it. So the only factorization I can do is take out a common 1, and that means I'm going to put it in brackets. There we go. Now after we do that, we're not close to getting it to look exactly the same as the right side. So we still have one more trick up our sleeve, which is this 3rd step. We are going to use identities. Now the only thing we can change here, which I can spot, is the cosine double angle. So what I'm going to do is I'm going to rewrite all of this again. There we go. And can you see I didn't write anything in the cosine double angle's place because we have 1, 2, 3 options. Now which one of these 3 am I going to use? Well, we usually use these bottom 2 when there is a plus or a minus 1 also in here next to the cosine double angle so that we can get rid of that plus or minus 1. So if there was a plus 1, I would have used this one and the minus 1 and the plus 1 would have cancelled out. Got it? Okay, but now because there's no plus or minus 1 in this numerator, I'm simply going to use this first identity. So I'm going to take it and then it's going to go in the place of the cosine double angle. And there we go. So now what do we do next? Well, we start all over again. We try and simplify what we just did. Well, this minus this I cannot because they're 2 different terms. Then I go and try and factorize. And if you look very carefully, this is a difference between 2 squares. So this becomes cosine x minus sine x. We close the brackets and we rewrite this bracket again, but this time the sign in the middle becomes a plus. And there is the difference between 2 squares done. And then we also have the denominator here, and because it's 1 term in my numerator, 1 term in my denominator, I can cancel this one as well as that one. And can you see my left side is equal to my right side? And we are done. Let's go and look at another example. Now in this following example, we want to prove that this left side is equal to the right side. Now again, this is not an equation. What we want to do is we want to simplify this left side, and in the end it should look exactly like our right side. So we want to prove the following identity. Now here we go. We start with our step 1, which is to try and simplify. Can I simplify this numerator? No, it's already 1 term. And can I simplify this denominator? Well, 1 plus cosine double angle, I cannot do that, so no simplification. Then we go to step 2, which is to factorize. Well, this numerator is already 1 term. The denominator, well, has a plus, so I can take out a common 1. But in this case, I'm not going to do it right now because I can simply spot here that this is a cosine double angle and I'm probably going to change it. So what I'm going to do is go to step 3, which is use identities. So I'm going to change this tangent theta with the quotient rule. I'm I'm going to change the sine double angle to its double angle identity, and I'm going to change this cosine double angle to its double angle identity. So I'm going to rewrite it, and can you see I leave these brackets because I'm going to do substitution of the tangent theta with this quotient rule. So I'm going to take sine theta, cosine theta, and put it in the place of tangent theta. So here we go, and there it goes, and it goes into the place of the tangent theta. And then in the place of the sine double angle, we are going to put the double angle identity. So there it goes, and it goes into the place of the sine double angle. And then in the place of this cosine double angle, we have to choose again between 1, 2, 3 identities. Now, like I said earlier, can you see here is a positive 1 with the cosine double angle, and we would really like to get rid of this positive 1. So which one of these two can I use? I'm going to use the middle one, because this minus 1 will get rid of that positive 1. Got it? So let's move it, and there it goes, and into the place of the cosine double angle. And now we have it written like this. Now, we start with our steps again, and that's to simplify. Well, here's multiplication. So can you see that this cosine theta, which is in the denominator here, will cancel with this cosine theta there. And there we go. Wonderful. And then here at the bottom, we can simply multiply this plus 1 into this bracket, and with the distributive law, and then we end up with 1 plus 2 cosine squared theta minus 1, and in our numerator we've got sine theta times 2 sine theta. Now, what do we do next? Here in the denominator, the minus 1 and the plus 1 will cancel out, and then these two can be multiplied, and then we end up with 2 sine squared theta, and at the bottom we have 2 cosine squared theta. These 2's will cancel out because it's one term, and then we've got a sine squared theta over cosine squared theta, which is equal to tangent squared theta. So our left side is equal to our right side, and we are done. See you again next time. Bye.